Hello, and welcome to the Microsoft Flight Simulator X non-official ATP check ride video walkthrough. This 5-part series lesson or walkthrough will guide you in everything you need to know to pass the ATP check ride. Although I will be working with the Boeing 737 aircraft, the general guidelines can be applied to any aircraft, especially those with autopilot built in. This guide can also be useful in just learning how to take off, climb, descend, prepare for and execute a full ILS approach, and land the aircraft. I want you to forget anything you have seen or learned in the past, especially on YouTube, unless you're sure you learned it from a proper source. Although you may see some things that you have been taught differently, I assure you that there really is no other way to fly this check ride in order to pass. In any case, this tutorial is here for you. Before I start, I highly suggest you get acquainted with the Boeing 737-800 aircraft, especially the autopilot. I will be flying most of the flight with the autopilot on. If you want to try and fly it manually, then go ahead, but it will be much harder. If you're going to use the autopilot, I highly suggest that you also turn on the auto rudder feature in your realism settings. I will give a short introduction here so you have some kind of idea of what I am doing, especially if you're a beginner. If you've already acquainted yourself with the locations of the various controls, you can skip ahead to part 2. Otherwise, you should watch this short introduction. This is your compass. This is your autopilot command switch. If it's on, you can control autopilot settings. However, if it's off, then you are in total control. This is your altitude hold switch. When it's selected, the autopilot will attempt to hold the altitude you select. Ever so, be careful to keep an eye on the altitude at all times, and always double check that the autopilot levels out at the desired height. Also keep in mind that you will need to set the appropriate speed to any given altitude. For example, the autopilot cannot hold 28,000 feet at a speed setting of 170 IAS. If so, the airplane will stall and crash. This is your altitude select knob and allows you to select which altitude for the autopilot to hold. This very important lever is your autopilot vertical speed or rate in feet per minute. Usually, the autopilot will select the automatic rate. Ideally though, you should change this rate suitably. When descending, you will see a minus sign to the left of the numbers indicating that the autopilot vertical speed is set to descend, and when the minus sign isn't there, then the autopilot vertical speed is set for climb. This is the autopilot heading select switch. When it's on, the autopilot will maintain or turn to the selected heading. This is your autopilot turn rate selector. It can be set from 10 to 30 degrees of bank or turn rate and plays a very important role in making specifically timed turns, and can be set by moving just a bit off the heading knob. This is your heading select knob. You can turn the button left or right to select the heading that you would like the autopilot to hold or turn to and hold. This is your nav1 or GPS hold switch. It is useful when you want the airplane to get to a specific location without having to worry about making fine-tuned adjustments to that location's heading and course. This is your approach hold switch and should only be switched on when you are ready to land and only if you have set the proper ILS frequency in your nav1 radio. Despite other tutorials I've seen and what is physically possible or comfortable for you, your airplane should be completely set for landing before reaching the glide slope intercept height or outer marker and before switching the approach hold on. In this aircraft and ATP check ride, your landing lights must be on, speed at around 150 knots, ILS frequency set to 109.3, course set to 159, flaps set to 30, speed brake armed, auto brake set to 3, and gear down. Ideally, your airplane should be somewhat aligned with runway 16 right at heading 162. This is your nav or GPS toggle switch. It is used to switch the autopilot heading hold of either the nav1 frequency or the GPS waypoint set. This is your auto throttle speed hold button. That is your auto throttle N1 hold button. That is your auto throttle hold switch. Auto throttle will only work if this is turned on or armed. It is an added security feature and makes the auto throttle work independently of the autopilot. So if you've turned the autopilot off and have left the auto throttle on, it will still continue to hold the selected speed, not something you usually want on final when landing. This is your auto throttle speed select knob in either IAS or Mach, which can be toggled by using the CO switch. I'll be using IAS, however some pilots choose to use Mach, especially when reaching high altitudes. This is your course selector knob and is vital in assuring that you are on the proper desired course to a runway or VOR. This is your flight director switch and allows you to toggle the autopilot director, which can aid you visually in what the autopilot is doing and what changes it is making, especially the pitch and bank. When flying the plane manually, it is usually better to turn this off, so as not to get mixed up with the autopilot. However, when flying with the autopilot, it should be turned on so you can see what the autopilot has planned. This is your autothrottle N1's head knob, and it is almost impossible to pass the ATP check ride without using it. This is your auto brake selector knob. This is your flaps indicator. This is your landing gear indicator. That is your landing gear lever. This is your speed brake indicator. When it's on or lit, your speed brakes are engaged. You should check your throttle quadrant to see how they are set. This is your small 3. This is your big 3. This is your analog pitch and turn indicator. This is your analog altimeter and airspeed indicator. This is your altimeter selector and should be tuned appropriately depending on weather and location, and could also be done by pressing B on your keyboard. This is your analog heading and navigation indicator. This is your NAV1 frequency needle or ADF needle. This is your NAV2 frequency needle. The analog indicators are there for additional information and for added assurance in case of an emergency, and will usually continue to work if there is a system failure. They should always be in sync with your digital indicators. This is your main throttle display. It includes, among others, your throttle and fuel gauge indicators. You usually want to land with the least amount of fuel possible, though on this short flight, that is not possible. Those are your N1 indicators for engine 1 and engine 2 respectively. Those are your N1 auto throttle indicators. This is your main panel heading display and has a map of common waypoints, VORs, and airports, as well as your current location. This is your digital heading indicator. This is your airplane ground speed indicator. It can be useful in calculating the approximate vertical speed required to descending or climbing to a specific location in a given amount of distance. This is your autopilot heading setting indicator or bug. If it's to the left, the autopilot will turn to the left when engaged. If it's to the right, then the autopilot will turn to the right when engaged. It's important to remember this when making a reversal turn, such as a 180-degree turn, and make sure that you are turning in the direction desired. This is your digital navigation or ADF needle. When it's centered, you are centered in on the nav frequency selected, the GPS waypoint, or the runway. It is also called a localizer. This is your airplane heading direction indicator. This is your airplane heading direction coordinator. This is your airplane heading turn coordinator and location. This is your NAV1 setting indicator. This is your distance to NAV1 in DME, nautical miles. This is your NAV2 setting indicator. This is your distance to or from NAV2 in DME. This is your current course indicator. This is your main panel display and digitally displays your pitch, turn rate, altitude, airspeed, heading, and other important factors. Whatever is pink indicates what your autopilot settings are tuned to. Whatever is green indicates what your settings are set to and indicates that they are on or engaged. This is your airspeed indicator. This is your airspeed coordinator. This is your altitude indicator. This is your altitude coordinator. This is your vertical speed indicator. This is your vertical speed coordinator. This is your heading turn coordinator and indicator. These are your pitch indicators. This is your pitch coordinator. This is your nose coordinator and indicator. These are your turn or bank indicators. This is your turn coordinator. That is your yaw or rudder indicator and coordinator. This is your local altitude readout and should be used mainly when landing, especially ILS, unless you know the physical altitude of the runway and want to subtract it from your current altitude. Although not displayed yet, this is your ILS glide slope and runway heading coordinators. The two pink diagonals are your ILS glide slope indicators. This is your chronograph, and is very important for timing turns, time to landing, and other important factors. This is your throttle panel toggle switch. This is your speed brakes lever. This is your parking brake. These are your throttle levers. These are your reverse throttle levers. These are your engine cutoff switches. This is your flap lever. This is your pitch adjuster or trim. These are your pitch coordinators. These are your pitch indicators. This is your overhead panel toggle switch. This is your kneeboard toggle switch. This is your air traffic control switch. This is your map window toggle switch. This is your GPS display toggle switch, and can be used to set waypoints which can either visually guide you to the location or be flown directly to using the autopilot nav hold switch. This is your radio display toggle switch. This is your ATC selected station, and is usually done automatically using the ATC window. This is your Nav1 radio selected station, and is used in guiding you to the place you want to get to, and setting the frequency for the ILS. This is your Nav1 standby radio selected station, and is used to switch quickly from station to station. This is your Nav1 standby switch. This is your Nav2 radio selected station, and is used in letting you know for what station you have left. This is your Nav2 standby radio selected station. This is your trim toggle switch. Now that I've given you a quick tour of the various controls and their locations, I will assume you know how to use the functions mentioned and will not get into how to use them specifically. And now that you've gotten acquainted with the controls, you're ready to continue to part 2 of this lesson.